Hello everyone and welcome to the last Ontotext webinar for 2019. Today's topic is Ontotext Platform, the fast track from an RDF model to a knowledge graph. My name is Yasen and I'm part of the Ontotext marketing team. Before we start the actual part of this webinar, I'd like to say a few words about the speaker and presenter today, Vasil Momchev, and also to clarify a few housekeeping items. So Vasil is the CTO of Ontotext, and as such, he is in charge with the product development. He has more than 15 years in software development in various domains like life sciences, pharmaceutical, healthcare. During the past 10 years, he's mostly engaged with the development of complex enterprise knowledge management solutions that features NLP, text analytics, reasoning, semantics, ontology design, linked data, conceptual model design, implementation of formal grammar and graph databases. Moving on to the housekeeping items, first of all, this webinar is recorded and a link to the recording will be added to a follow-up email. For practical reasons, you are all muted, and this is to avoid background noises, but you can still communicate with us via the question box in your GoToWebinar panel. In case you have any questions during the webinar, don't hesitate to write them, don't hesitate to ask them, just write them at any given time in the question box. At the end of the webinar, we have planned a short Q&A session in which we will address some or all of the questions. And in case we don't have the time to answer all of the questions, we will add the answers to the follow-up email as well. With that, I think it's time to move on to the actual part of this webinar. So I'll give the word to Vasil.
Hello everyone, welcome to this last webinar for the year. This is an educational webinar where I'm going to talk about knowledge graphs, and this webinar is related to the release of the Ontotext Platform 3.0. Today's focus will be on the knowledge graph and how to express APIs for their consumption. So we are going to have a quick demonstration of the Ontotext platform. The structure of today's presentation is that you're going to get some background. What are actually knowledge graphs and what is this hype around them? Second, we will talk about common architectural approaches and pitfalls we have seen during the design of knowledge graphs. The third item will be the Ontotext platform features and what you can expect to get out of the box as a product. And last but not least, you get just a demonstration of the platform, its documentation, and how this works in practice. So before to jump into the technicalities, why really we speak about knowledge graphs and what is the market demand? I'm really happy that somebody tried to quantify this, what we have seen for many years working with the industry. By average, the big enterprises actively use less than half of their structured data. And when we talk about unstructured data, this percentage is even less as 1%. So the demand of the knowledge graphs is how to design a better agile systems in order to improve these percentages and ultimately better use the knowledge, which will lead and result a better decision-making process. Ontotext in the last 15 years is really dedicated into our making sense of text and data. So we design knowledge type of systems and extract metadata from various type of documents like unstructured text, video, and content. And also we link these to third-party or proprietary for the client's master or reference data in order to design knowledge graphs. But what are the features of the knowledge graphs? Every knowledge graph, according to our terminology, has 4 very distinctive features. First, it should be really natively a graph model, which should enable you to augment the knowledge in all different directions, and it should not have a fixed schema. So graphs allows you really to extend it with additional data, and this gives you really the required agility of adding new data. It should support obviously semantics. Semantics is really important because just dumping data will make another data silos. And semantics is really putting the data in the right context and to know where it comes from, what is the metadata to describe this, and to have some sort of shared understanding what is the meaning. Smartness is something very important because once you create this type of a knowledge graph, you can do some sorts of analytical algorithms like graph centrality or automatic reconciliation based on the graph topology and the similarity of the nodes. And this smartness is really giving you a faster way to integrate data. And on last, every knowledge graph should be alive, because if it's not updated, it will very quickly become out of date and the knowledge inside will be no longer relevant for the organization. If you really want to check some more data, how to make semantic and smart graphs, please check my Connected Data London presentation, where I'm really talking about how to connect entities in an automatic way. And today's presentation focus will be mostly on consuming the data once you have built a knowledge graph, how to consume it and expose this to the end users. So why knowledge graphs? And basically, okay, it sounds as an interesting idea, but what is really the added value for an organization? Obviously, the very first big challenge, and this was really the demand of the market, is how to unlock the data, basically, which resides in different silos applications. And these silos applications are often designed because of these organizational boundaries. They are not really technological limitations, but this is how the big enterprises operate and save their data. Typically, they design transactional systems to serve a very particular business process. Often, the people need an analytical power across the organization and how to combine this data. Second, one very appealing reason is that we see a trend how the people try to combine data management and analytics technologies. No longer people want to really create data quality and do data governance without really integrating machine learning algorithms for a smart interpretation. So knowledge graphs is really an option to see how to combine data governance and management classical technologies with the data analytics. And this seems to be a converging field where the two technologies want to speak each to each other. And every knowledge graph should have some filtering capabilities to provide quality data, and also this data should be suitable for further analytics. A third very important aspect is really the agility. There are tons of data warehouse systems which really are designed for the last 30 years and trying to solve this silos problem. And these are mostly operational transaction data. And these data warehouses, they are probably doing some good job in answering questions. One of the major differences and difficulty with them is the agility. Often when you design the really smart systems, you don't know all the answers in the beginning. So one of the requirements is really to have an agile system which can be quickly changed with the demand of the business and the IT owners of the systems and how you really want to use this data. And last but not least, and this will be the special focus of the today presentation, is knowledge graphs. They connect really data providers and consumers. And there should be a really shared standard how consumers and providers interact, and they have all these type of analytical capabilities and obviously agile way how to communicate and to evolve the schema. So we move to the second item of the agenda, which is the architectural approach, where we are going to compare if you have on one RDF data model, what are really the different options of exposing this and what are the pros and cons. The very first and natural way is the direct database access. This is a very old approach existing from the client server applications, where the clients, there were TIC clients and they were accessing the database directly. The classical communication between a client and database will be, I'll give you a SPARQL query, and then I get the results and render them in my application. This is still a very common way how people are using this technology. GraphDB has this feature of providing anonymous access, and we have quite a number of public services like DBpedia, FactForge, and other, which are operating exactly in this mode. The client really consumes the data, do some small sort of queries, and then render it to the client. What are really the challenges with this approach? First, it's really highly efficient. Obviously, this is one of the big advantages. If you design a system like a FactForge, which gives you the access to the full DBpedia and Wikidata data, it's very easy to start consuming this data because you don't have to design any backend servers. You just go connect there and consume the data. Also, this is a fast way because you can micro-optimize every query and you have direct access to the data. You can really fetch only the data you need and you can customize every query. Clearly, there are big disadvantages of this approach. There will be a strong coupling between the application logic and obviously the model. As soon as the model changes, probably the application will never understand that that model is changed and it will stop working. So with respect to this, we don't consider this as a very agile approach because every time you change the schema, you need a lot of testing to make sure that you get the same results and that the application continues to function. Another common pitfall is that every consumer of the data, they should implement the logic how to interpret and consume the data. And this stays in all clients. So every client who is consuming this data must implement the same logic. So this logic will not be shared by any of the clients. Another really very common challenge is the security model. Once you introduce these to security experts, they will not be happy of allowing all their end users hitting directly the database. And then the database should be responsible somehow to secure all relevant data. This is like masking the important documents from the public documents. And this is really a challenge, and you would be difficult to pass any security audit test. And last but not least, we as maintainers of one of these public services, I would say that it's extremely hard to operate these type of systems because giving access to the SPARQL database, everybody can send all sorts of queries intentionally or unintentionally. There could be Cartesian products, complex functions, and you need to spend a lot of effort really to cut off the legitimate from the other type of requests. So once again, the operation of the database becomes difficult. Although this is publicly available and many people are using this approach, we don't consider this as very agile unless you want to put relatively static data to be consumed by other users. The second approach is the REST API, which is really the dominant way how to design and build applications. In this layer, there is an introduction of an extra application layer which sits between the client and the database. And the REST API has some good practices how to create, read, update, and delete objects. So in this case, we have really human, which is an object from the ontology, and this human object will be really requested. I want to get human by ID. The REST API will call it a SPARQL query or a describe query, which will take the data. Most likely it will be taken in a JSON LD or another easy to parse format. And then this REST API may decide how to filter the information to apply some business logic and to return it. It's even simpler if you have to create data, because the REST API may have some data validation and to reject data which seems not valid. Also, all the logic will be the same for the clients because they will be passing through the same interface. One of the advantages is that all data access logic is shared between the clients and you implement it in one way. This is very useful, especially if you want to modify data, because you ensure consistent URIs and consistent schema and validation across all clients. Another big advantage is that you can change on the fly the underlying database without any of the clients to fully understand what's going behind this API. And also, Enforcing security and throttling is easier because you have a much more control over what type of operations you expose to the end users. Obviously, this is not without any issues. One of the big challenges is that REST APIs, they don't give you a really good information. What is the schema of the information and what is the types you can query. There are some standards how to do this, but mostly they are not universally recognized, and you should rely on some public documentation of the API. The classical way how you evolve your model once you want to change this is to make versioning. So the next time you want to change the human to be no longer human or to have a different set of fields, you need to version your API and to increment this. And this sometimes can be cumbersome because you need to update your API version to work with two different versions. Another common problem is the under and overfetching. This means that the REST API returns the full description of the object, and sometimes this may be problematic. If you just want to get one or two particular fields, you don't have to download the full resource. Another common problem is REST APIs typically require some multiple round trips to the server. This means to collect all the information, you want to get the human, then to download all the films it participates, and all these are different calls. And this is difficult to batch. This generates an extra load network and latency for the client application. In general, the REST APIs are good only if you have resource-centric APIs like getting and deleting data without having very interconnected data. With the evolution of the APIs, there is a new type of a technology on the market, and this is GraphQL. GraphQL uses a slightly different paradigm, and this is a query language for the API. It's somehow compatible with the REST API, and it allows to overlay this. The difference between the GraphQL and the REST API is that the client states what is the data it needs. In this particular query, it says, I want all humans, their names, and then the planet they live. So it's up to the GraphQL engine to satisfy this query and to decide whether it's going to get this from the database, whether it's call other REST APIs, and how to retrieve this data. The common pattern is that in such way, you design a generic APIs and the client may request only the data they need, and this can be done with a single round trip. You don't have to modify the REST API if every time you need to add a new feature. Obviously, it has all the benefits of the REST APIs because somehow this is not an alternative, but this is a complement to the REST API. And also it adds some good features like the decorative schema and strong types, allowing you really to understand what is this API can offer to you and can guide you what are the fields you can consume. It also comes with a very rich system of tooling, integration with the application development environments where if the schema changes, you get automatic notifications and the client will notify you that this API has evolved. Also, the APIs is very comfortable for doing upgrades of the data because by default everything is new and it's really well designed to support the schema evolution. And not last, but it can integrate other REST APIs or stitch schemas from other type of services. So its primary way is really to combine and aggregate multiple enterprise APIs. Obviously, this has the cost. The server implementation becomes much harder because the server should be, the GraphQL engine should be able to handle all different type of requests, do all the joins, and this is a much harder implementation. Naturally, all the requests in GraphQL are post, so the caching key also becomes harder, and generating the GraphQL schema may be a laborious process. So, having said this, I want to introduce what is the scope of the GraphQL platform. The GraphQL platform should eliminate these type of problems and give you an easy way how to design schemas out of ontologies and design the backend interfaces directly for you. So you can start designing the applications directly from the ontology. What are the Ontotext platform features? I will make a quick overview. of the main functionalities we offer. The core functionality is the Semantic Object Modeling Language, and this language allows to bridge the gap between the RDF model and the GraphQL. Roughly speaking, this table shows how the Semantic Object Modeling Language corresponds with terminology with RDF, GraphQL, JSON-LD, and shapes. So in this modeling language, objects are roughly close to RDF types. So roughly say that you can expose every RDF type to think that this is a different object. In GraphQL, these are type or time name with the schema introspection. In JSON-LD, this is really coded as types, and in shapes, this is a not shape, allowing to validate the data. The modeling language supports also inheritance. Inheritance is important to model hierarchy of objects, but also in GraphQL, you can use these interfaces and copy fields to avoid duplicating fields data. So you can design abstract types, which really integrates common fields, and they can be reused without any copy pasting. There is no such thing in JSON-LD and shapes standards. Properties are really roughly an equivalent to the properties in the RDF model. So for every type, you can design what are the properties. And once you design this property, it will be automatically generated as a GraphQL field for this type. The same is really applicable to JSON-LD, where we have also properties, because this is another just a serialization of RDF model. And in shapes, this is a property shape, which can limit and validate the data. We have also support for ranges, which gives you what is the target type, which is implied by GraphQL, because for every property, you should know what is the target type and the field. This is roughly equivalent to the schema range includes, which is similar to RDFS range, but it can list multiple types there. Okay, so this is the modeling language which we'll quickly introduce here, and we'll show how we can expose any arbitrary RDF model and quickly design an RDF model and GraphQL API from it. So in this example, because we had just the release of the Star Wars, we are going to get one Star Wars dataset, which is collecting coded characters, films. We have loaded it in the RDF database, and now the task will be really to expose this as a workable API, which we can give it to the clients, and they, with the minimal development time, start consuming the data. So this semantic object model example, we'll type that we have a film, and this film is RDF type, which means that everything which is RDF type of VOC film will basically become a GraphQL film type. Every film has a name, which is RDFS label, and this is roughly mapped to the property. And every film has these properties, and which is really characters, basically the people who, the characters, the fictional characters playing in this film. We have description of the film director, episode ID, which is really a native integer value. We have planets, what are the planets appearing in the film, starships, and so on. As you can see, some of these properties has cardinalities, which says, okay, whether this is a single value or this is infinitive. And also for every film, we have the release date when this release was published. So GraphQL API generation is the process where the platform will automatically generate these types from the SOML description. These types is how GraphQL works, and the platform will do this automatically for you. So in the previous type, we are going to get a GraphQL film, which implements nameable and object interfaces. And every of these films have characters. The characters have ID, limit, which means you can limit the number of characters per film return, offset. This is like in SPARQL language, you can get the limit and offset, order by or where clause, which allows you to limit the type of characters which we want to get. And obviously the film has directly related properties like description, director, episode ID, and so on. So this description basically guides to the clients and gives the semantics, how they consume the data, and underneath the Ontotext platform is going to translate these SPARQL queries. What else Ontotext Platform offers is the efficient transpiling of GraphQL to SPARQL queries. And there is a very different nature in the execution. GraphQL queries are executed top-down. So in this particular query, we say, return me all starship which are operated by Luke Skywalker, get the films where Luke Skywalker participate, and order them by starships based on their speed and cargo capacity. So the typical type of a query is you start top down. You are going to get the Luke Skywalker. This is the identifier of Luke Skywalker, which is human.1/1, and we are going to get for him the ID, name, gender, birth year, and height. So the film means this is a nested entity, and it will allow us to get all films, but ordered by name. Unlike SPARQL queries, there is a top-down execution order. It means that in a SPARQL, typically, the query starts with, not typically, but by spec, they start from the subselect, and then you bind all the parameters, bindings from the outside queries. In GraphQL, this is the opposite. You are going to get the Luke Skywalker, and then if it participates in any films, you are going to populate them, and then you are going to get the starships. From API perspective, this is a much more natural way how the users consume data, because it gives you a really way to navigate, to get one object, and then to dig down for different details. So one of the questions here is, how many people out of you can really write this as a SPARQL query? It sounds as a simple query, but let's see. Okay, for those of you who even try to do this, I will disappoint them that actually this query is a relatively complex one. It's really a long query. I don't want to go in details because you probably not even see it. But getting the right data and extracting it with SPARQL may be quite difficult, especially if you're not very familiar with the schema. The first thing is that we bind the human, and then there will be a number of optional values, because if there is some value which is missing, we don't want to filter out the results. And there is a list of optionals getting the data. Another thing is that there is a subselect which should get all the films. And naturally, this query also has a different semantics, which is really not the way how the standard SPARQL works. Because in the standard SPARQL, first the subselects will be executed, and then only if there is internal results, they will be further enriched. And also, we will not be able to get, for instance, all the characters ordered by something, then all the films ordered by something, and then all the starships ordered by something. If we have an outside order, it should be basically override the ordering of all the other variable bindings. And for this, we have a specially implemented very efficient SPARQL implementation, which changes semantic of the SPARQL in order to make this type of queries highly efficient, and probably much more efficient than you can hand code using the standard GraphDB SPARQL endpoint. So what else? We are going to go, I'm quickly going to the demonstration. Since this is really a platform, it gives you all these operational dashboards where you can monitor all types of infrastructure, processes, and so on. And this is really the overall architecture of the Ontotext platform. What is in there? One of the objects we have been just presenting is this Semantic Object Service, which allows you to expose GraphQL endpoint on top of GraphDB. Obviously, the platform has many different type of features, which is everything who operates on top of GraphDB, which is a semantic database, standard RDF database, allowing you to index all sorts of semantic data. In the data layer also, we operate with MongoDB. MongoDB is stored for all the documents and document annotations, which can be produced by text analytics type of services. Another type of is the Elasticsearch. For the people familiar with GraphDB, you know that we index a lot of data in Elasticsearch in order to make some queries faster to operate. Obviously, there in the service level, we have machine learning models for integration of data and so on. One another important aspect is the Apple Federation, the Apple server, which allows you to extend the logic of the GraphQL by stitching different type of APIs and add some own custom logic. The application layer, it comes from the GraphDB workbench for ingesting structured data and obviously querying RDF data, and also the GraphQL interface, which is the equivalent of GraphDB workbench or GraphQL, which allows you to test your GraphQL queries and to consume the data. In the later demonstration, we will see more. Everything is packed as a platform with Kubernetes. Kubernetes is a Docker orchestration service which allows you to efficiently build solutions and orchestrate different types of Docker services and to operate them. The platform also features a standard security which allows you to query, to filter users, and it integrates a standard identity management type of service. The operational layer, which we have seen on the previous slide, collects metrics for all the Docker instances. So once you really you run this platform, you start noticing what is really the performance of GraphDB, how many SPARQL queries are executed, what are the GraphQL queries running next to the platform. As a more general direction, the way how we integrate and ingest data is using services like Kafka and Spark for distributed processing, and this is really the knowledge graph creation. We'll just mention this on the platform picture, but we will not go in many details. Our build process is that most of these services are in Java, and we really release this using Jenkins, and our internal version control system is GitHub. So what are the extension points of the platform? Before we are going to the demonstration, the Ontotext platform is really a layer which enables software developers to quicker and faster develop knowledge graphs without the need to design backends. The Ontotext platform has an efficient SPARQL, uses the SPARQL language to communicate with GraphDB. It has some improvements in order to get better performance. There are extensions in the SPARQL, so the platform requires GraphDB. The platform comes with access control, monitoring, and also it can federate and integrate with other type of systems externally and publish data. The classical user interface for knowledge graph is probably Angular, React, or another type of a JavaScript framework for directly implementing the application and the consumer of the data in a web browser application. Naturally, the easiest way to communicate this is using the GraphQL and queries and mutations for modifying the data. Obviously, you can also still access GraphDB using the GraphDB JavaScript driver and to consume data directly from the SPARQL endpoint. If you are aware what are the limitations of the direct access, which was something easy presented earlier. Also, GraphDB is an open architecture which give you many ways to extend its operation by pushing logic closer to the database. GraphDB, since version 9, has open source plugins. So there are a couple of open source plugins. We have seen that in GitHub there are some community contributed plugins as well. So the plugins allows you to push logic very close to the data. The typical plugin will be an analytical algorithm which will reconcile automatically data and will do something which needs to have a direct access to the data. Other ways to extend the GraphDB is using SPARQL JavaScript functions, where you can just encode some logic, push the JavaScript function next to the code, and this will be executed by the SPARQL query engine. And obviously you have the connectors, which allows you to communicate and synchronize data with external systems like MongoDB or Elastic, which can be further easily consumed by the platform for other reasons. The primary interface for managing GraphDB is still the GraphDB workbench. You can import tabular data and just to manage the data. So this is really the overall Ontotext platform architecture from architectural point of view and how you can extend it and customize it. So now we go really to the demonstration and to get the feeling what is the Ontotext platform. I have prepared, so the simplest way is really to show you the platform is to get the minimal version of the platform. So in this case, we have a Mongo service, GraphDB, GraphQL API, and obviously the GraphQL to SPARQL translation. So everything is Dockerized and can be easily bootstrapped on a single machine. In this case, we really run the minimal version of the platform where we are going to run only the core components of it. So the platform is starting now with all core components. Okay, and now we see that the GraphDB is also working. So just to show you what is the data we are going to explore, is I'm going to connect. Okay, this is the GraphQL endpoint. I just, before to go there, I just want to show you what data we have. Since this is the Star Wars data set, I'm going to join the class relationship diagram and to explain the different types in order to get familiar with the data. So we have the type film. Basically, these are all the films we have, and the films are connected with the characters. So we have films, characters, species. These are the type of characters, what is their type. Obviously, we have planets. In the Star Wars, there are multiple planets. There are starships. For every starship, we know what is its speed, cargo capacity, who piloted, and so on. We have also human subtype and some vehicles, which is really a super type of the starship. And there are some minor types. So the natural way how we typically export this is using RDF, is that you come here and you say, okay, I want to search for a Luke Skywalker. And the natural way is you get this type of an API. It's a very convenient interface for navigating the data and to understand that this is Luke Skywalker. If you click, you get some description when it was born, its height, hair color, and all the type of metadata. So one way really to explore this is, let's see what is really the starship of Luke Skywalker. And there are two starships. One is the Imperial shuttle and the other is X-Wing. And this is easy to navigate the data and to understand who are the other pilots who pilot the X-Wing or the Imperial shuttle. Also, we can uncover the films here and to see what are the other characters or what are the planets participating in this. The diagram will show only the first 20 type of entities. So this is a very natural way how to navigate the data and to export it. One of the challenges is that this visual diagram is easy to navigate, but once you have to program this, you need to write SPARQL queries. And this might not be so simple to really consume the same type of data. So I will give you really one short tutorial how you can see this. On top of this data, we have described the SOML object, which is automatically generate the GraphQL. And this is linked to our documentation where you can see all these queries. The documentation also integrates into it GraphQL interface, which you can interactively execute these type of queries. So this query will list all characters, their ID, name, gender, and so on. So we can just execute this type of a query and get the results from the GraphQL endpoint. It's even further easier if we want to write down our own query, because the GraphQL allows you to have an autocomplete guiding you what is the schema. In this case, we will say, okay, we want to take the name, the identifier, the eye colors, and in this case, we are going just to close this, and we say, in this case, we get all the characters which participate in all the Star Wars film movies. We have the raster. One of the important differences compared to SPARQL is that if you don't get any values, you get no. This result will not be filtered like in the triple join queries, which will filter this result, which could be quite confusing for the newcomers of the SPARQL language. As we progress, we can get all more complex type of queries, and where in these characters I'll use this example. We want also to join other interconnected data. So the characters, as you have seen in the model, are connected to fields. So for the field, we can take what is the name of the field, what is the description, what was really the release date. So in this case, we will see not only what are the characters, the AI colors and so on, but also the fields which they feature, like the phantom menace, what was the release date, there is no description here, and so on. So I'll scroll down and give you the equivalent of the above query which we have seen with the visual graphs. So in this particular case, we are going to search for a character with the ID human1, which we have seen. This was a Skywalker. In this case, we get the same data, and if we have to mimic the same operations we were seeing, we'll be basically browsing. I want to take all the films, and once again, or in these films, I want to take also all the planets, and in these planets, I want to take their name. This is very useful if you want to design a user interface which wants with a single operation to go collect all this data, but only the data it needs, and to visualize it. If I have to make an analogy with the REST interfaces, typically this will be done in multiple round trips. You are going to get the character Luke Skywalker, then you have to ping for every film to get the data, and so on. With GraphQL, you can just make one single query, and then the GraphQL engine will smartly try to optimize and plan this query, get all the data as efficient as possible, and return it to the client. So here we have a much more complex examples with nested types, which we have seen, and also the GraphQL API gives you the ways to sort the results as well. In this case, once we have declaratively said that height is a numeric value, automatically the platform will generate that these results can be sorted ascending or descending. So this query gives you, tell me what are the highest characters in the Star Wars films. And we see that the highest character is Yara Poof, who is 264 centimeters. So we go down a little bit, and probably we are going to reach this type of a complex query, which was demonstrated earlier in the presentation. We want to take Luke Skywalker, all the films he participated, order them in ascending order, then take the name and find all the starships and their maximum speed, and basically. So in this query, we see that Luke Skywalker in the movie New Hope, the fastest engine he piloted was TIE Advanced X1, and it had atmospheric speed of 1,200 kilometers. And probably, let's see what was the slowest one. You can obviously very easily reverse this type of a query. And we see that this was CR90 Corvette, which was 950, but obviously it had a much bigger cargo capacity. One of the nice things is that the GraphQL offers you automatically generated documentation, which is also maintained by the Ontotext platform. As soon as you update your semantic object modeling language, you'll be able to automatically see all the difference in the model in production immediately. So there are plenty of different type of queries, which plays you how we generate, what is the GraphQL API interfaces we generate. And there are really a lot of features about listing objects, filtering, doing regular expressions, doing offsets, all things which might not be so trivial to be done in SPARQL by newbies. So really the key message is, once you design your ontology, by adding few more decorative mappings to our semantic object modeling language, using it, you can directly generate the GraphQL API, which will allow you to consume much easier the data. Obviously, for some type of queries, you still need to access directly the SPARQL database, but for most of the developers and data consumers, this will be a much easier and natural way of consuming data. I will just show some of the filters because the GraphQL API and the way how we implement this also allows to get where clauses in the same way like in SPARQL, and to filter only characters which are we have equal male, and then we see how many of the films, and once again we can join and extract off of various types of data. And there are probably many different types of examples in our documentation. You can check this in order to see how everything is generated. I will not go in very big details. I'm just going to show you some of the dashboards which are operated and usable, presented once you really run this as a platform. So you can monitor the GraphDB cluster, what is its load, what are the components, the RAM usage, and all the important details, who is really consuming the data, and important operational metric. So in this operational metric, we can also register external third-party services like Docker containers, like machine learning models, which will make the data consumption, which can enrich the data model with different features. So I'm going to the last slide, and this will be like a wrap-up of the Ontotext platform. This is our way how we develop data management and analytic applications. Obviously, it's tailored towards big graphs and complex metadata management scenarios. It's relatively easy to handle billions of statements as a master data, to maintain them, to unify and reconcile them. We can deliver very quickly solutions like linking different type of data sources. In this example, this was just the Star Wars data set, but in the enterprise setup, we can work with big data source of reconciling and integrating a lot of data. This technology is really enterprise ready. It query performance scales. You can add additional workers. The scalability, we can sustain a large number of concurrent read requests and also operational transactional updates per second. We as a company, we are doing a lot of text analytics and graph analytics. So our core value is how to unlock data from unstructured documents and to enrich the knowledge graph with data which exist, which to further enrich the knowledge graph with the knowledge locked in these type of documents. And obviously, not least, but the delivery model is important because we want to very quickly put into production these type of systems to get reasonable hardware. This platform is cloud agnostic, so you can run it on any of the big cloud providers or on premise in the way how you decide this. So I think this is pretty much the full presentation, and I'm going to open the question window and leave 10 minutes for question and answering session. Okay, so the first question is really, is it possible to have a copy of the slides used for the seminars? Obviously, you are going to get the recording and also the slides. They are a Google document which will be distributed. Okay. So what else? Let's see in the window. Okay, so here is an interesting question. Do you support mutations? Yes, we do support mutations in the documentation. They are not exposed, but in the realities, yes, it's something which is in our roadmap. Actually, it's now available in the platform, and you can also modify the version, the data. The mutations are using JSON custom types to really create and modify the data. So the next question is, as it comes, is there a Docker image with a free license? No, we don't publicly allow this as a Docker image. If you want, you have to contact us, and then we can arrange a demonstration, a further targeted demonstration, and we can discuss the commercial terms. The next question is there a schema involved? Is it based on ontology? Probably I have to go back in my presentation and to stress, or maybe to ask the question in more generic way. Is it possible to generate the semantic object modeling language from OWL? Sorry. Yes, it's possible, and we have scheduled in the next versions that this type of modeling languages can be derived from OWL. So basically the schema, the standard ways you can apply this platform on top of any schema. You just tells us what is the data, what is its structure, what are the range, descriptions, labels, and then the platform will automatically generate for you all the GraphQL endpoints, and this is a way how it works. So yes, it works with the ontology, and this is your actually ontology. The meta model kind of this ontology is this modeling language which gives which parts of the ontology to be exposed as a GraphQL. Okay. So we have another question coming. I understand GraphQL have upper hand to SPARQL in query writing. Is GraphQL faster than SPARQL? Okay, so there are two questions here. Is GraphQL faster than SPARQL? Probably. So if it's really about reading data, I believe GraphQL is much faster to write queries because it's an easier question, it's easier language. Obviously, it has some limitations, but all the queries which you can write down in GraphQL, it should be much faster for the developer. Our typical scenario in enterprise setup is that there are a couple of SPARQL experts which are responsible for maintaining all the SPARQL queries in the project. So by using the Ontotext platform, you can lower this burden and allow every developer to easily consume the data by giving them a stricter schema of how to consume and produce the data. From an operational point of view, I believe that we have a very efficient GraphQL to SPARQL translation, so I don't think that you're going to experience any major overhead if you want to issue one and the same query in SPARQL or GraphQL. Sometimes we don't limit the SPARQL endpoint, and if your solution needs really to access the SPARQL, you can still do this, and this is very useful if you want to do some sort of a graph path searches, property paths, or something which is not trivial to be exposed in GraphQL. So yes, the GraphQL does not eliminate the SPARQL endpoints. So the simple message is for standard queries of consuming data, it just makes it simpler and faster, but it will never eliminate the SPARQL and the complexity of the RDF when you need it. The question is that not every developer should start with this interface. Okay. The next question was about the query writing and how is it faster to write data through mutations or SPARQL. Actually, once we speak about writing data, then we go what is standardly available in GraphDB. The performance of the data writing is really one and the same, and this is as every database. The limiting factor is how big is your database and how small are your transactions. If you really bomb any database with tons of small transactions, then the performance will not be good. Still, if I go to this architectural picture, there are sometimes use cases where you want to store huge amount of small documents, and this you need a massive write performance. In this particular case, we can redirect the GraphQL endpoint to point directly to MongoDB and then to produce JSON-LD files. So JSON-LD is a valid RDF. You know, GraphDB has a connector for reading JSON-LD documents from MongoDB. So if you want extreme scalability, then you need to compromise the graph database, and you just need to store them in a document database where you can retrieve them in a fast way. Okay. So there are some follow-up questions. So faster means execution time. Yes. In general, the question is what is the overhead of sending one GraphQL query to SPARQL? I think we have measured this. It's a very minimal overhead. And the other thing, what I want to stress is that the type of execution we do is really highly optimal, because this is the typical SPARQL queries we execute. The integration is that the GraphQL endpoint is going to generate one substantially big SPARQL queries. SPARQL query, this SPARQL query will have a different semantic in order to make it more easily to read. In this particular case, the query execution path will be, it will execute the first part of getting everything about Luke Skywalker, and then it will execute the subselect. Naturally, this is if this is a standard SPARQL endpoint, it will execute it in the other way. So you can think of adding, we have added a new MIME type of a SPARQL optimized for GraphQL in order to make this performance as fast as possible in order to get this design highly performant systems. Okay, I think these were all the answers, all the questions in the Q&A session. If you have any further questions, don't hesitate to contact us. You have the details on our website, and we'll be more than glad to jump into a more focused session where to understand your use case and talk how we can work together. So thank you, everybody. I was Vasil Momchev. Greetings from the Ontotext team. I wish you very pleasant and happy holidays, and bye from me.
Goodbye.